Hi, I'm Ilkay Altinas, and I'm at UC San Diego, as mentioned, at the San Diego Supercomputer Center and Halo Data Science Institute. And my groups develop workflows for many scientific disciplines. So I'm going to talk about the Wildfire technology based on PRP today. But I also want to take a moment to say we used PRP for many other applications, smart manufacturing with GP Lee and others at UCSD, COVID IoT analysis for medical IoT with Benjamin Smart at UC San Diego. We used it for medical image analysis together with heart and brain analysis with Mai Nguyen and Mark Ellison's group and Matthew Madany. So it's made impact already in a number of different areas. And more special to me, or more importantly to me, I teach the master's level capstone class here. And over the years, our students were able to use PRP for many types of projects, and this made it really a positive experience for our students, and I think it stands out as an educational infrastructure as well. So I would like to thank both Larry and Tom here for their leadership on that. And wildfires, of course, as we speak, we have a severe drought. It's gripping us in the Western United States. Last year was the worst fire season by any measures in history, but this year we are really bracing for worse, unfortunately. So, but wildfires has been in activity at UC San Diego for a long time, together with, starting with, I should say, the HPWREN, High Performance Wireless Research and Education Network, funded by the National Science Foundation initially. And over the last decade and a half, actually since 2001, since it was funded, HPWREN added networking at the back county of San Diego. And on these mountaintop radio nodes in a wireless fashion, it added environmental sensors and cameras on mountaintops and across the county. And some of these are weather stations installed by both HPWREN and our energy power company, San Diego Gas and Electric. And also the mountaintop cameras that sees the county in all directions. So during a wildfire, actually, we could see and sense the environment, and in real time, we can have some understanding of what's going on out there. And for a long time, from 2005 to 2010, it was the only situational awareness platform that someone could see the fire. Thinking of satellite technology a decade and a half ago, we didn't have these satellite detections of the fire or how it's moving. So this was transformational, and it inspired us in different ways. But as you can imagine, this is a lot of data, and especially during a wildfire, the demand to HPWREN increases. And as a networking infrastructure with some storage, it adds complexity. It adds complexity on responsiveness, because suddenly, a site that you have 100 people on, maybe less, spiking up to hundreds of thousands, tens of thousands, it's not easy for a cyber infrastructure project to handle. So HPRP was used to add nodes for responsiveness of this important infrastructure. And it added capabilities for data redundancy in terms of data failures and disaster recovery, more for resilience, fault tolerance to the network. It made it highly available for projects accessing the data. And also it made it dynamic through containerization of software and data to use the data coming from the HPWREN. And the servers were across the PRP, but these real-time weather stations and forecast data, and that comes through PRP to our servers in the WIFIRE project. And through a workflow, the WIFIRE project combines it with other things we know about, aircraft, fire perimeters, landscape, and combines it with fire modeling tools, so we can then communicate the direction of a fire to the authorities or the decision support or decision makers as a decision support tool. So let me take a step back. You've seen an overall workflow. This is a part of, as I mentioned, the WIFIRE project. WIFIRE, inspired by what we've seen in HPWREN and UC San Diego, and by the wildfire problem overall and potential help from technology. It was built by the National Science Foundation support as a cyber infrastructure to bring data and modeling tools together to then give us bits of information on the rate of spread and the perimeter and the direction of the fire. So we could then use it for decision support and management of the fire. So when you bring together data like that, of course, there are things that we can do before, during, after a fire. But what I'm talking about is during the fire scenarios today. And during the fire requires urgent cyber infrastructure capabilities as well. So, traditional waiting on a batch queue, and, we don't have time. We have minutes in the Southern California, especially when you think of, for instance, Los Angeles. If a fire starts, they have probably a couple of hours before it burns to the ocean. So they need to respond fast. They need to understand the direction so they can manage it right. So the task is not controlling a fire, because it's wind-driven often, the type of fires we have, but it is getting ahead of it by understanding where it's going to be so it could be managed. So PRP definitely helped us both from getting access to data in a scalable fashion perspective for parts of the data, as I mentioned, like the HPWREN, but also having that peace of mind that if there are multiple fires, and if our server infrastructure that we built, which is, as I mentioned, the urgency of it requires some on-prem or cloud infrastructure, we can switch over to a more scalable form through PRP support. So everything that we built is cloud compatible, and PRP made us also have peace of mind in terms of the cost of the activity as a research project. But also, during the fires, there is the public interest. This actually surprised us. In any large-scale fire, starting with the October fires in 2017, since we started tracking it, I should say, somehow public got to understand what was going on, and this become WIFIRE's fire map become the situational awareness interface for the public. It's an interface that brings together information about the current fire, weather, satellite detections. And we are noticing now with each fire, hundreds of thousands of citizens, public, in essence, individuals, coming to our websites for situational awareness. And we will not give them the direction of the fire, where it's going to definitely not cause chaos, but anything else about the officially announced information and the sensed information about the fire is available to the public. And I think the simplicity of the maps and seeing it all together really gives peace of mind or situational awareness to the public. So we are having millions of page hits, which requires scalability. And having it built on top of a scalable platform definitely helped with that. And the modeling activity, right? This is growing. And over the last 10 years, since we, excuse me, since we had built WIFIRE, the AI revolution has happened. So we have more data and more use of real-time curation through machine learning and AI. And we prepare the data using also training, large volumes of imagery and things like smoke detection, things like understanding weather patterns and what Santa Ana means, what Diablo winds means across the California environments. So definitely the demand is increasing. And during the fire, some of these can take place as well. So one of the things we've done was to start looking for how we can combine the PRP with large-scale infrastructure. And this inspired also SDSC's latest supercomputer funded by the National Science Foundation, the Expanse supercomputer. Expanse has a number of sort of innovative features, but one of them is composable systems, which is the integration of the supercomputer itself through a part of supercomputer being reserved as a Kubernetes cluster, just like the PRP cluster. So we can federate the supercomputing resource and the large-scale supercomputing nodes together with the nodes, the GPUs, and other heterogeneous node capabilities in PRP. So this type of composability is transformational for our type of work because we can now have a heterogeneous workflow. One part needs large-scale capacity, like the supercomputing capacity, and one part needs more specialized capabilities, like the GPUs, FPGAs, and things like that, that we can pool together and federate together on top of a data fabric. And this is more kudos to NSF for recognizing the need and really funding this type of capabilities there. And just as a side note, we are using Bright Cluster Manager. So we are having both Slurm and Kubernetes-based capabilities in one interface in Expanse. That's one of the secret sauce behind on top of Kubernetes. And what we've done, then we use the Admiralty capabilities for data federation. So for cluster federation. So now the Enthalpy, the Kubernetes cluster within Expanse, is federated together with Nautilus, and we are now able to overlay a heterogeneous workflow to execute across these different environments on top of an object storage capability and Ceph file system. So other good things have happened. There's the edge computing and the digital continuum that comes with it. So another thing NSF funded over the last 5 years, or 3 years actually, is the SAGE AI at the edge environment. This is a capability to add accelerators together with sensors across the networks like HPWREN network, NSF networks, Neon, AOT, and other networks as well. And the idea is then to have edge sensing capabilities and couple that to this heterogeneous workflow so it can trigger computations, both in the machine learning and physics-based fire modeling sense. So this type of capability enables, in essence, smoke detection at the edge in a high-resolution form or high-resolution weather analysis, fuel and moisture analysis at the edge, and using that when there's a smoke detected, for instance, moving to the cloud-based or PRP and Expanse-based urgent computing platforms, this dynamic Kubernetes federated clusters to do fire modeling. So when you look at it, it looks like a simple thing to achieve, right? There's 3 things and you're running a workflow, but it's not always as easy. So what we are doing is now trying, or we demonstrated the capabilities of running this workflow and as a simulator for SAGE. We have the SAGE virtual platform running on Chase CI, and through simulating that smoke detection capability that's not ready for real-time deployment, but this type of things we need to prepare so we could actually launch it when the capability is there. And once the smoke is detected through the WIFIRE gateway on top of Chase CI and our on-prem clusters, we actually run the smoke detection to fire modeling workflow across this federated cluster.
Okay, we've got to wrap things up. We're running a little short on time.
Yes, and just last thing I'll say about this is now the next steps. It's becoming quite the community platform through the Jupyter Hub. So whatever we are doing ourselves is extensible through data and model commons. So we can bring models together, train models through an AI gateway we built on top of the PRP, so that we can link data and models to user environments and capabilities through the PRP. So this is the next step and the future. And sorry for that couple minutes too long talk.
Well, you do so much good work, Ilkay. We could have a whole day workshop on just your stuff.